Dear students, our next chapter is chapter 3, water. We know that the formula of water is H2O. Chemical name of water is dihydrogen oxide and the molecular mass of water is 18 atomic mass unit. We already know how to calculate the molecular mass of any compound. Since we know that the relative atomic mass of hydrogen atom is 1 and this formula of water contains 2 atoms of hydrogen. So 1 into 2 plus relative atomic mass of 1 atom of oxygen is 16. So plus 16. So 1 into 2 plus 16 is equal to 18 atomic mass unit, which is the molecular mass of water. Now we know that water is the most important natural resource. About 70% of the Earth's Earth area is occupied with water, out of which 2.5% of the water is fresh. And we also know that water exists in all the three physical states, and thus in the solid state as ice, in the liquid state as water, and in the gaseous state as water vapor. Water also occurs in the free state as well as in the combined state. In the free state we can say water of lakes is the water which is in the free state, and in the combined state we can say body fluids. All the body fluids contain water, but it is not pure water. Then water also has one important property, that water is able to dissolve wide range of substances. Since water is able to dissolve variety of substances, wide range of substances, it is called as the universal solvent. And this characteristic property of water, that it is able to form solution, is responsible for the water pollution. This characteristic property of water, that water is able to dissolve wide range of substances, is the basic cause of water pollution also. Now, the water which we use for drinking purpose, if that water contains some suspended impurities, like suspended impurities means the impurities which does not dissolve in the water, which remains in the suspended form in water, that impurity can be removed by the method of filtration. And if water contains dissolved impurities, then it can be removed by the method of distillation. And if some bacterial impurities are present in water, then all those impurities can be removed by adding some calculated amount of chlorine in it. So these are some of the ways of just separating the impurities, of just purifying the water. Next topic is physical properties of water. First property is nature of water. Pure water is clear, transparent liquid. It is colorless, odorless and tasteless. But the pleasant taste of water is due to the presence of impurities in it. लेकिन जो pure water होता है वो colorless होता है, odorless होता है और tasteless होता है. Next point is boiling point. Next physical property of water is boiling point of water. We know that at normal atmospheric pressure कितना होता है 760 मिलीमीटर ऑफ मरकरी या फिर 76 सेंटीमीटर ऑफ मरकरी और 1 atmosphere. These are the standard values of the pressure. It is the normal atmospheric pressure. So at normal atmospheric pressure, pure water boils at 100 degrees Celsius. We know this very well. But the boiling point of water is affected by the pressure. Boiling point जो होता है water का, it is affected by the pressure. It changes with the change in pressure. Because boiling point liquid का वो temperature होता है. Boiling point of a liquid is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. वो टेम्परेचर जिस पे लिक्विड का वेपर प्रेशर एटमॉस्फेरिक प्रेशर के इक्वल हो जाता है, दैट टेम्परेचर इज कॉल्ड एज द बॉइलिंग पॉइंट ऑफ द लिक्विड. So first of all we should know that what is vapor pressure. Vapor pressure क्या होता है? For that you take this diagram. Suppose we have taken one closed container. One lid is kept here at the top of this container. ये container closed है and this container contains some water in it, and the air which was present in this container is evacuated out with the help of vacuum pump. अब इसके अंदर vacuum है. Now we are providing heat to this container. जब आप इस container में heat provide कराएंगे, then the temperature will increase, means water molecules will become more and more energetic. Now we know that in between the water molecules interparticle space is not very high, but there is some interparticle space, and therefore these water molecules are in constant motion. वो move करते रहते हैं, they collide with each other. So when heat is supplied to this container, when heat is provided here, then these water molecules will become energetic more, and as a result those water molecules which have kinetic energy more than the average kinetic energy, those water molecules will move up and they will evaporate and they will enter into the vapor phase. So how it happens? Because those water molecules which have average kinetic energy, on absorbing heat they will become more energetic and they will collide with those water molecules which are present at the surface of the water. अब वो वाटर मॉलिक्यूल्स जो कि वाटर के सरफेस पे प्रेजेंट थे, उनकी काइनेटिक एनर्जी ऑलरेडी एवरेज से ज़्यादा थी. जब कोलिजन फेस किया उन्होंने, then their kinetic energy increases much more and they start evaporating and they enter into the vapor phase. So they will move upward, they will evaporate, and as a result they will strike with the lid of the container and they will again come back. At the time of coming back, some of these vapor molecules will again condense and they will again re-enter into water. जो वाटर के मॉलिक्यूल्स एस्केप हो रहे हैं और एंटर कर रहे हैं वेपर फेज में, उनमें से कुछ वेपर के मॉलिक्यूल्स क्या करेंगे, कंटेनर के लिड के साथ में स्ट्राइक करने के बाद में, कोलाइड करने के बाद में, दे विल अगेन कम बैक एंड दे विल अगेन कंडेंस एंड दे विल री एंटर इनटू वाटर. So at this stage, what happens? These vapor molecules exert pressure at a particular temperature, and that pressure is called as the vapor pressure or saturated vapor pressure. Means एक जब ये water molecules escape होते हैं तो उस टाइम पे क्या होता है कि एक स्टेज ऐसी आती है जब evaporation की रेट और condensation की रेट, मतलब वेपर मॉलिक्यूल्स जो कि स्ट्राइक करने के बाद में वापस कंडेंस होके वाटर में एंटर कर रहे हैं, तो रेट ऑफ इवेपोरेशन और रेट ऑफ कंडेंसेशन एक पर्टिकुलर स्टेज पे आके इक्वल हो जाती है, और उसी स्टेज पे ये वेपर के मॉलिक्यूल्स एक्सर्ट करते हैं प्रेशर को. उसी प्रेशर को हम सैचुरेटेड वेपर प्रेशर या फिर वेपर प्रेशर बोलते हैं. So we can say that the pressure which is exerted by the vapors of the liquid at a particular temperature is called as the vapor pressure of the liquid. Now we come to the boiling point. Suppose we have taken again one container and this container is not closed from the top. In this container also some water is kept there. When we provide heat to this container, then those water molecules which have kinetic energy more than the average, they will start escaping, they will start evaporating, and as a result they will enter into the vapor phase and vapor pressure phenomena will be created over here. But one more factor is here, that atmospheric pressure. Now since this container is open, so it means that gaseous molecules will be here. Atmospheric pressure होता क्या है पहले तो हमें ये पता होना चाहिए. So we know that atmosphere is the envelope of gases and the pressure which is exerted by these gaseous molecules on the unit area of the earth's surface is called as the atmospheric pressure. The force which is exerted by the gaseous molecules on the unit area of the earth's surface is called as atmospheric pressure. So when the जब यहाँ पे हम क्या करते हैं, हीट प्रोवाइड कराते हैं, हीट प्रोवाइड कराने की वजह से जो वाटर मॉलिक्यूल्स हैं वो इवेपोरेट होना स्टार्ट होते हैं एंड द फिनोमेना ऑफ वेपर प्रेशर इज क्रिएटेड हियर. लेकिन ये एटमॉस्फेरिक प्रेशर जो होता है, मतलब जो गैसियस मॉलिक्यूल्स होते हैं वो क्या करते हैं, फोर्स एक्सर्ट करते हैं इन वेपर मॉलिक्यूल्स के ऊपर और उनको वेपर फेज में और उनको एस्केप होने से रोकते हैं, जो गैसियस मॉलिक्यूल्स होते हैं वो. अब वेपर प्रेशर को मतलब वेपर मॉलिक्यूल्स को एस्केप होने के लिए यहाँ पे क्या करना पड़ेगा, हमें मोर एंड मोर हीट प्रोवाइड करानी पड़ेगी. अब हमने अगर हीट को कंटिन्यू रखा, व्हेन कंटिन्यूअसली हीट इज प्रोवाइडेड टू दिस कंटेनर, तो फिर इवेपोरेशन की जो रेट है वो बढ़ जाएगी. More and more water molecules will become energetic and they will enter into the vapor phase. Liquid evaporation rate increase होगी हीट के इंक्रीज कराने पे. जब हम हीट को इंक्रीज करा देंगे तो फिर एक कंडीशन, एक स्टेज ऐसी आएगी जब वेपर प्रेशर जो है एटमॉस्फेरिक प्रेशर के इक्वल हो जाएगा. Once again I repeat, when heat is provided to this container continuously, then the liquid evaporation rate will increase and as a result one stage will come when the vapor pressure of the liquid will become equal to the atmospheric pressure. So that temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure is called as the boiling point of the liquid. So we can say that boiling point is the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. Also, the boiling point of the liquid increases with the increase in atmospheric pressure and decreases with the decrease in pressure. ऐसा क्यों होता है? क्योंकि अगर प्रेशर इंक्रीज होगा, प्रेशर के इंक्रीज होने की वजह से हमें ज़्यादा से ज़्यादा हीट प्रोवाइड करानी पड़ेगी इस कंटेनर में, जिससे कि वेपर प्रेशर इंक्रीज हो और फिर वेपर प्रेशर एटमॉस्फेरिक प्रेशर के इक्वल हो सके. So when the atmospheric pressure will increase, then the vapor pressure will become equal to the atmospheric pressure at the increased temperature, and as a result the boiling point of water will increase because the temperature at which the vapor pressure becomes equal to the atmospheric pressure is the boiling point of water. In the same way, when atmospheric pressure decreases, then the boiling point of water decreases. And this phenomena is also used in the hills. That we know that as we move to a height in the hilly areas, atmospheric pressure decreases as we go on a height. Then when the atmospheric pressure will decrease, then it means that boiling point of water will decrease. और जब water का boiling point decrease होगा, इसका मतलब ये है कि अब water की जो boiling है वो कम temperature पे start हो जाएगी. As a result, food is not properly cooked there. So इसी वजह से हिल्स में क्या होता है, हम प्रेशर कुकर को यूज करते हैं क्योंकि प्रेशर कुकर में ट्रैप्ड स्टीम की वजह से प्रेशर इंक्रीज होता है और जब प्रेशर इंक्रीज होगा तो फिर बॉइलिंग पॉइंट जो है वाटर का प्रेशर कुकर के अंदर इंक्रीज हो जाएगा. बिकॉज वी नो दैट इन द हिली एरियाज ड्यू टू द डिक्रीज इन द एटमॉस्फेरिक प्रेशर बॉइलिंग पॉइंट ऑफ वाटर डिक्रीजेस. इट बॉइल्स एट अ टेम्परेचर बिलो 100 डिग्री सेल्सियस. So food is not properly cooked there. Therefore, we use the pressure cooker over there because the trapped steam in the pressure cooker increases the pressure, and as a result, the boiling point of water also increases. Due to which the pressure cooker absorbs sufficient heat from the cooking stove in order to reach up to that temperature. उस temperature तक पहुँचने के लिए ज़्यादा heat absorb की जाती है. As a result, food is cooked properly in the pressure cooker and also food is cooked faster in the pressure cooker. One next topic is there given in the book about boiling point is that the boiling point of water increases due to the presence of dissolved impurities in it. ऐसा इसलिए होता है जब भी हम वाटर में, प्योर वाटर में एक नॉन वॉलेटाइल सॉल्यूट को या फिर किसी भी इम्प्योरिटी को ऐड करते हैं तो जो वेपर प्रेशर होता है सॉल्यूशन का, फाइनली जो सॉल्यूशन हमें मिलता है आफ्टर एडिंग द इम्प्योरिटीज इन इट, सो द वेपर प्रेशर ऑफ द सॉल्यूशन गेट्स लोअर्ड in comparison to the vapor pressure of pure water which contains dissolved impurities in it, उसका वेपर प्रेशर कम हो जाता है. Now in order to make the vapor pressure equal to the atmospheric pressure, more heat is provided to that solution, जिससे कि liquid evaporation rate ज़्यादा हो जाए, और liquid evaporation rate जब ज़्यादा हो जाएगी then the vapor pressure will increase, vapor pressure का जो phenomena वो increase होता जाएगा, and at a particular stage vapor pressure will become equal to the atmospheric pressure. So when the impurities are added to pure water, then the vapor pressure of the solution decreases. Now in order to make the vapor pressure equal to the atmospheric pressure, more heat is provided, and at an increased temperature finally the vapor pressure becomes equal to the atmospheric pressure. So we can say that the boiling point of water increases with the by adding the impurities in it.